So, before we get started into the quantum model and electron configuration, I want to quickly review the Bohr model that was in a previous lesson. So, if you remember, this is what a Bohr model looks like. Okay, you have your nucleus inside, and then you have electrons going around. The Bohr model states that the electrons orbit the nucleus like the planets orbit the sun, so circular motion. They're at a specific distance, the energy levels. Okay, they're in rings, right? And that's kind of how that works. It's kind of set and it looks almost 2D like. Now, of course, it's a little bit more than that in the real world, but that's kind of how the model works. In the quantum mechanic model, which is the other model we're going to look at, which is the one that we really it's the modern one. It's the one that most scientists, or almost all scientists, um, look at today. It states that electrons orbit in like a complex manner. They're kind of like spinning in a 3D manner around the nucleus. Electron configuration is used to explain this 3D pattern. We're going to take a look at electron configuration in more in depth. And then there's 4 quantum numbers that we're going to look at with this. The first one is the orbital energy, which is labeled as N. That's again our rings. There's the orbital shape. There's S, P, D, and F. There's orientation, and then there's spin. So we're looking at, all right, which energy level is the electron on? Which shape is it in? How is it oriented in that shape? And then how is it spinning? Okay. Atomic orbital is the region of space where an electron exists. Okay, now we cannot predict where it exists, or we cannot definitively say where it exists. We can predict, we can get close to it, but electrons are moving super fast all around, so it's not like you can pinpoint exactly when something's, but we can predict generally where it's at. So orbital energy or size, it's the amount of energy levels. Okay, that's the period or the row that the element is in. Okay, so we can have 7 of them because there's 7 rows, right? So electron shell 1 through 7. N equals 1, period 1, N equals 2, 2, all the way through to 7. Orbital shape, it describes the shape the orbit will look like. Sometimes it will look like a sphere, sometimes it looks like a dumbbell, sometimes it looks like a clover, things like that. There's S, P, D, and F, and those are going to be very important when we start to do electron configuration. Okay, and so these are our shapes right here. Like I said, you have the orbital, the P orbital, it looks like a dumbbell, it's really close together. The D kind of looks like a clover or a flower. Okay, and the higher up the letter, the more pieces there are. Orientation, these shapes are subshells, okay, the S, P, D, F, they're split, okay, into individual orbitals, okay, and this is where they're oriented in space, and it's how they're placed in that specific orbital. Um, a lot of it is a lot of orbitals will only hold, all orbitals will only hold 2 electrons, and they have to be facing certain ways and things like that. Okay, so here's our kind of our how it looks. It's an XYZ scale. Spin is the direction your electron spins. Okay, the number of electrons in an individual orbital, there's 2. Okay, the max is 2, and they either spin clockwise or counterclockwise. Okay, so they'll either spin up or down. Okay, so this is kind of how it looks if we're looking at an electron or an atom and the electrons moving around. It's more of a 3D type shape. So electron configuration, which we're going to go more in depth with, it's the arrangement of elements based on their electrons and their energy level, their shape, and then their spin. Okay. So in your notebook, you will have the different blocks. So the S block is the first 2 columns. Okay, columns 1 and 2 on your periodic table. The P block is the last 6 columns on your periodic table. The only thing I will mention is that helium really belongs in the S block right next to hydrogen. Um, it's one of those things like hydrogen, because of its properties, really should be above fluorine in certain cases. And then helium, because of electron stuff, should be really next to hydrogen on the other side. So that's why it's kind of weird the way they're set up. But just know that helium really should be next to hydrogen. The D block, I like to call it the little squatty block in the middle. That's where our transition metals are. Okay, so it's columns 3 through 12 in our periodic table. And D block is really important because D block, when you are dealing with it, is when we're doing electron configuration, you're going to see that it actually changes its energy level. And then F block is the 2 rows, the actinides and the lanthanides that are on the bottom of your periodic table. Okay. So understanding each block, S, P, D, and F, there's a maximum number of electrons associated. S only holds 2 because there's 2 columns. Because there's 2 columns, they only hold 2. P has 6 because there's 6 elements if you're going across the row in the P block. There's 6 columns in the P block. D is 10 because if you count them up, there are 10 elements in each row or each period in that block. And then F is 14 because there are 14 elements in each row for there. And then we're going to use that when we're writing our electron configuration. These numbers, 2, 6, 10, and 14 are going to be very important when we're writing our electron configuration, excuse me. So remember those, okay? S has 2, P has 6, D has 10, F has 14. So that's pretty much the quantum theory in a nutshell. Now we're going to look at how to write an electron configuration.